K-fold cross-validation. When we're training these models, as you train them, you'll see that you don't always get the same answer. And that would be expected if you're using a stochastic gradient descent optimizer, stochastic being the key word there, right? So you're not always going to get the same answer. So if you look at this here, what I've got here on the left is a plot for training a MINTS dataset classifier. And I have accuracy and I have count. So this is the number of models that I've trained and the accuracy. I trained 500 different 5 detectors, all with the exact same parameters, right? But they don't all get you the same accuracy. So on a couple of them, it's a little hard to see, but I actually got some down here and some out here that are like 85% accurate. And a couple I got some 98% accurate, right? But the majority of them I actually kind of got around, let's call that 94% accuracy. So not great, accuracy, relatively distributed. Now the problem is every time I train this model, I have a general idea of what I'm going to get, but I don't actually have a very good idea of what I'm going to get. And lucky for me, this data set's pretty big. But as data sets get smaller and smaller, it gets harder and harder for you to certify that the model is going to train to a very high quality every time. Here's the exact same things for precision and recall, right? Nothing's changed. It's just you can look that I have a pretty big distribution from about 40% precision to 100%, and from about 35% recall to 100% recall. Not great, just kind of is what it is. So we can solve this by using something called K-fold cross-validation. And in K-fold cross-validation, what we're going to do is we're going to split our data set up into a number of folds and slices, and then we're going to use that data to train individual components, right? So if we do that, first we'll look at some results. We'll get these results here, which are K-fold, which are just much more tightly bound, right? Now you will notice that the general peak of the accuracy, precision, and recall all comes down, right? Now, if you're trying to sell a product, maybe you just report this model. You train 500 models and you report the best one, but then you will have some very unhappy customers. So, if you're a startup company, you could probably try that route. But if you're an established company of 100 years reputation, right, your reputation is more important than getting something out the door. So you would want to sell a model that's going to work very well every time. So K-fold cross-validation is a way that enables that. And let's take a look at what that looks like. I'm going to shrink it down just a bit. Okay, so first we're going to take all of our data and we're going to split it, right? 80% and 20%. And now on my training data, I'm going to split it even more, right? I mean, nothing that we love more than splitting up data into chunks. So we're going to split it into a number of folds. And here we might have fold 1, 2, 3, 4, 5, 6. And now of those folds, I am going to, these colors are inversed. I am going to train it on 6 of those folds, and I'm going to validate it on 1 of those folds, right? And now what I'm going to do is that's going to allow me to get my proper parameters data. And I can do that. So I can do that once, and then I can train it again, right, on my next fold. And I can validate, I can train with a different number of folds and validate with a fold that's not in the training set. And now I can do that on 6 different splits, right? And so on each split, I can get a different number of thetas. I can then merge all my thetas, get my average thetas, right? Those are just my parameters that I'm going to use. And now I have these parameters that have not been, for lack of a better word, contaminated by my test data, right? So my parameters have not seen my test data. And now when I test it, I can actually evaluate it on the test data. Otherwise, if my parameters have seen my test data during the training, then I will end up with a model that isn't completely disconnected from my test data. So I don't actually know how well it's going to perform, right? I'm overfitting it or overcompensating for it. So something to think about as we build these sets up. sklearn gives you several good tools to do this. So you can add this to the pipeline, which is sk.model underscore selection dot cross underscore val underscore predict, right? So you don't actually have to go through and tell sklearn like in a for loop to train 7 models. You can just feed it into the k-fold cross validation. And then you can have that in your pipeline. Again, this is why pipelines are so efficient in sklearn. And then it will do your validation out. And the defaults in there are an 80-20 split. You don't have to do an 80-20 split, but it's definitely the default and probably the way to go.